So again, here, getting back to equations, okay, we have f of x equals mx plus b. This is a polynomial, okay? The graph of this is a non-vertical line. So these are polynomials. But these are examples of polynomial functions as long as m is not 0 or b is not 0 or both. If they're both 0, you do get a polynomial actually. It just doesn't have a degree. Finding the domain, if you have an equation, it can be a little tricky as we have here. There's basically two rules you want to follow, so to say. One is you never divide by 0, which really is the same as saying denominators can never be 0. And also, you never take the square root of a negative number. In this class, we don't do that because we're not considering complex numbers. And also, as another type of function that you do study a lot if you go on beyond math, beyond this class, is rational functions. That's just when you have one polynomial divided by another. But again, the domain of that is all numbers x, so that the denominator is not 0. Because again, you never divide by 0. One example of that comes from this example, x times y is 1. Because if you divide both sides by x, you get this. And this is an example of a function. The graph we'll see in a minute, but you can see right away the domain is all numbers except when x is 0. That is, the domain is all numbers except 0. The graph actually looks like this. And you can even see from the graph that 0 itself is not in the domain. If you go to 0, let me see if I can draw it, and you go up or you go down, you're not going to intersect the graph at all. So 0 is not in the domain. We also saw the square root function, and we already said that the square root function, we saw the graph of it, it's all numbers except 0. No, excuse me, it's all non-negative real numbers. So the domain as an interval is this. Because again, you don't take the square root of a negative number. For the next example, okay, here, we want to find the domain of this. This is a function. You have one polynomial over another. One is a polynomial. It just has degree 0. The denominator is a quadratic, a polynomial of degree 2. We want to know what the domain is. So we want to know when the denominator is not 0. Well, we're going to find that. First, we're going to determine when it is 0, and then we're going to throw those numbers out. So for this, I use the quadratic formula. So using the quadratic formula here, okay, what we get is -1. So that's when this is 0. That's the solutions to this. So the domain is everything except -1.